So earlier I made a video series on building this rig here. It's kind of a basic, simple humanoid rig. We have kind of the core features of IK arms, IK legs, but we also get into some more complex things like IK FK switches for arms and legs, creating special groups to allow systems to work independently. For example, the FK legs here not bending with the torso, or other areas like the head toggle here, where the head doesn't rotate with the chest, or we can toggle it to rotate with the chest. Now, this is a relatively complex series of controls. It is a step towards creating a full production rig, a full character rig, but the reality is, for a lot of people, this is overwhelming. And more importantly, for their needs, sometimes it is excessive as well. So what I want to talk about in this series here is going to be the MVP version of this. And to an extent, we kind of did this with this character, but what if we went more minimum? And once again, if you're just joining us, MVP stands for minimum viable product. What would that look like for a character? So the minimum viable product for a character rig at the end of the day is pretty simple. If we go ahead and take a look at the torso, this stays an FK system. We can work our way up to the neck and the head. This continues the FK system of the torso. And if we go ahead and take a look at something like the clavicles, these can also be FK as well. Where this diverges a little bit is, what do we do about the legs and the arms? The arms and the legs can be simple IK systems with no switches required. Now, this also brings us out to something like the fingers or the feet. Do these need a complex reverse foot setup, IK FK switches? No, they really don't. With the hands themselves, we could use an FK system, or in reality, we could just create a custom control that allows us to bend the hands, depending on what our needs are. And the same goes with something like the foot. We don't necessarily need a fancy reverse foot. We could just simply give it a ball control. So, in what scenario might we use this? This would be an example of a simple control for something like a game. In many instances, in mobile games, in games that are far away from the screen, where characters are small, in RPGs, we don't need a super complex rig. We can create a very minimal rig, and what this video is going to take a look at is that process. How do we build this simplified rig? So if any of you are joining us from the previous rigging series, maybe you got overwhelmed, you got lost, this video is going to be a great place to start to just kind of get a basic rig up and running and to understand how to get this rolling. Now, I am going to start this a little ways into the rigging process here. I'm going to start us where we basically started the control rigs, and we've gone ahead and we've attached the skin to it, all right? So just a reminder, we have two separate rigs. We have the skin rig. This is the rig where we did our deformation, where we painted our skin weights. And you guys can check out the previous video in the series on doing this. I have a 3-step process of joint setup, weight block out, and then weight refinement. And then the next stage was connecting this to the control rig, which once again, we have a video for, so I encourage you guys to check that out. And that will be where we kind of pick up today. So we'll be picking up here where we have set up our control joint system here to control our skin system. All right, so that's going to be where I am picking up with this rig. So just so you're aware, watch through those first few videos. I believe this one's kind of the first one in the rigging section, and I'll link them down below so you guys can find access to them in the comments. They'll also be part of the playlist that this is going to be grouped in, so you guys can check that out. So let's go ahead and begin the process here, and I'll take you through the process of building these core controls and kind of getting things started. Now, before we begin, you guys can download a series of rigging controls from my Gumroad. I'm going to be utilizing those here by coming into the import section here. Under my characters and my rigs here, I've saved these into the rigging assets, control rig collection, and we can just import these guys in. All right, so I'm going to utilize these to kind of build this rig kind of quickly. That way I don't need a sample from them. If you are working with this for the first time, just remember you have to unparent these to attach them where we want to go. The other thing is make sure you have your toggles here for the geometry visibility and the joint visibility. In this particular case, this is my control joints here, it says. I want to make sure my skin joints have their own layer, so I'm going to add those to a layer. I'm just going to make this my skin underscore joints. Set that to a reference and turn those off and make sure I'm just working with my control rig here so that way I can see it. Now, when we're building the system, what I'm going to do is I'm just going to go through the process of building the FK systems first, and then we'll get into the IK systems. So for the FK system, we're going to essentially have our spine up to our neck and our clavicles all connected into this internal position. So we're going to have a root control here. That's going to control the center root. We're going to have a hip control nested within that, and we'll talk about that in a moment. We'll have our spine one. We'll have our chest. We'll have our clavicles here. We'll have a neck. And then we'll have a head. And once again, these are all going to be part of an FK chain, a very simple FK system. Now, to facilitate this, let me go ahead and just grab one of these circular ones. I'm going to hit Control-D to duplicate, Shift-P to unparent, and then V to snap to vertex onto the skeleton. With that selected, I can go ahead and enable the skin and just make this wide enough for me to see. This will represent my hips. I can then duplicate this up, Control-D for the spine, check the size against the geometry to make sure that's good. And then I can do the same thing here for the chest, which should be fine. And we'll go ahead and start with this. So this is going to be my main root for my FK. Now, the other thing I'm going to want to do is I am going to want to come in here and grab something to represent my center of gravity control. Usually I like something that looks a little bit visually different, so I'll go with this squiggly line circle here. I'll just Control-D, Shift-P, unparent, and I'll snap to vertex here. And this is also going to go onto the root. So we're going to essentially have two root controls, and that may not make sense yet, but we'll make sense of it in a moment here. So let's go ahead and freeze the transforms on these. I'll just select them all, modify freeze transforms. And from here, we're going to use our standard FK setup. Now, remember with the FK setup, we're going to create something called an offset group. And the point of this offset group is going to be to store the orientation of the joints. Do you need these? Yes. You do want to have these for a lot of different reasons. If you guys don't understand joint orientation, what I would suggest doing is putting a group above your control, because it will allow you to do some things later that are kind of nice. So if you don't fully understand the offsets, it's still good to have these. Now, I usually like to build these in my hypergraph hierarchy. So we're going to come in here to Windows General Editor Hypergraph Hierarchy, which is kind of a hot mess here, but we're going to focus at the end here because this is going to be where these pop up. Now, before I move forward, let's go ahead and name these. I'm going to name this first control my hip underscore CTRL for control. This will go ahead and be my spine underscore CTRL for spine control. This will be my chest control, so chest underscore CTRL. And then this one here, you guys can either refer to as the root control, the center of gravity control, or short for center of gravity is COG. I like to use root control. Now this is going to represent the root movement of the entire character. From here, we can go ahead and set up some groups. I'm going to hit Control-G with nothing selected to create my null. I'm going to select my root control, shift select my null here, and do a constrained parent, but I'm going to make sure maintain offset is unchecked. What that will do is it will make that null jump into the exact orientation of this group. You'll see it gains the translate. And what I mean by group, I meant it's going to gain the exact orientation of the joint. And that's what we're looking for. From here, we can go ahead and delete that null. And then we just want to parent the control that's going to be under that null underneath it. So I'll select the control, shift select the null, P to parent. And if we take a look at this, you'll see this curve gained transforms because it's getting that orientation information. What we want to do is make sure that the null retains whatever transforms are here, translates, rotates, scales, any of that kind of stuff. But we want to make sure that we are freezing transforms on the control. And what that's going to do is it's going to guarantee that this control has the same orientation information as the joint. Now, I'll go ahead and repeat that for the spine. Control-G, we'll select the spine joint, shift select the null, do a constrained parent, make sure that maintain offset is turned off, and just apply. And just like before, we'll delete that constraint. We'll go ahead and select the curve, parent it to the null, freeze its transforms on the control. Control-G again, select the chest, shift select the null, perform our parent constraint, delete the parent constraint, select the curve, parent it under the null, and then freeze the transforms. Now from here, what we can do is we can go ahead and select the control back to the joint and do a parent constraint by hitting apply. If you have the correct orientation, you don't need to worry about maintain offset being on or off. If it is off and your controls jump, it means you didn't do the orientation correctly. But if you did your orientation correctly, this should be seamless and you should have no issues. What this will now do is it will make it so each of these controls controls their respective joints. But an important thing we need to do is rebuild the hierarchy. So what we need to do here is basically say who controls what. So for example, the spine is going to control the chest. However, this is where things diverge a little bit. The hip, we don't necessarily want to control the spine because we want this to maintain its independent movement. And that's where this root control comes in. We can take this root control and we can actually take the null of the hip control and parent it underneath it. And what that will now do is allow this control to control the hip one-to-one, while allowing us something to parent all these controls to that allows us to have this isolated. So let's take a look at that. What I'm going to do is instead of taking this null and parenting it to the hip, I'm going to take this null and I'm going to parent it to the root. So we'll select the null, select the root, P to parent. And what you'll see now is when I move the root, it moves the spine. When I rotate the root, it rotates the spine. But when I rotate the hip, it maintains its independent rotation. And this allows us to do hip lifts and swings. So we'll go ahead and take the chest now, and we'll go ahead and just take that null, parent it to the next curve and line here, the spine, and we'll have our basic FK system here for the trunk of the body. Now, what we're going to do is continue this up to the upper portion of the head and the torso. And like I mentioned, we don't need to get super fancy here. We can just keep this FK system. Now, for those of you who followed along with the initial video series, you're probably going to recognize this exact same setup. This really does not change from system to system. What is about to change is how we approach the upper torso, because in the upper torso in the video series, I show you guys something called a broken hierarchy, where we basically have these outside of the FK system. We create toggles that allow us to create switches. And what I'm here to say is you don't always need that. So let's take a look at this process. Let's go ahead and work our way up just to the neck and the head real quick. To continue the chain, what I'll do is I'll just create a neck control here. We'll use a nice circle. Control D, Shift P if you're using my system. Once again, Control D, duplicate, Shift P unparents it from the group it's nested under. And we'll make this big enough to represent the neck. Now for the head, I'd like to have something that we can see a little bit more clearly, something like this here. So we'll go ahead and hit Control D, Shift P on that. And we'll have something that represents the head volume. Now I'll need to take a moment here to shape this to be the correct shape for the head. And just remember that you want to keep that pivot there, but you can always come in here to things like the control vertices, and you can edit these independent of the pivots, meaning that we can move these up and we can shape these to fit our head while maintaining the pivot on this section there for the neck. So with this, we'll just freeze transforms on both of these, good practice to get them into place. And then we'll just proceed to create our standard FK system. Before we do that though, let's go ahead and keep our naming going. We'll name this our neck underscore CTRL. We'll go ahead and name the other one our head CTRL. And we'll go ahead and set up our standard FK system here. So I'll create a null. We'll select the neck, shift select the null, do our constrained parent with maintain offset. I have it baked into there, so we're good. Parent that neck control underneath, freeze its transforms so it maintains orientation. Repeat this process with the head, select the joint, select the null, do that parent constraint, delete the parent constraint, and nest this underneath here. Just so you know, I'm using G to repeat last command on the parent constraint. It's the reason you did not see me press the button. At this point, I'm assuming you guys know that. We'll just freeze transform there. Now from here, we just continue this down. We're going to take the null and we're going to parent that right to the chest of the neck. And then we'll take the null of the head and we'll parent that right to the neck of the torso. So at this point, we have a very simple FK system where the chest controls the neck controls the head controls itself. Now, I forgot a crucial step, which is making them control their respective joints. So don't make that mistake. But what's nice is the underlying structure is really all that matters before we move forward. So what I can do now is just select the curve, select the respective joint it controls, once again do a constrained parent, and repeat that process with the other control constrained parent. And now you can see that in action. All right, so neck, it's going to control the neck, head's going to control the head. Now, like I mentioned, this differs a bit because I used a broken hierarchy for these, and we had a custom attribute which basically allowed us to make this not follow with the body. You can see at this point how that's a nice to have. It's not a requirement, and that's one of those things that we want to look at when we're looking at something like an MVP, is a lot of the things that I go over in that series are nice to haves and really not required to get a character up and working. Now, we can take the exact same approach with the clavicles. We really don't need anything fancy. We mainly just need them to follow with the torso. So what I can do is find a nice clavicle control, and I usually like to use these nice arrows here. We can go ahead and Control D, Shift P to unparent these. We can go ahead and turn off our geometry, snap these up here into the arms, rotate them so that we can actually see what they look like. And once again, remember, this is just about placing something for an animator to grab. It doesn't need to look perfect or match perfectly. So something like that reads very quick, and I think it works out pretty well. It's a little bit thick. I might also just kind of rotate it a bit, so that way it's a little bit more even. And what I can do here is just freeze transform. You can then duplicate this with Control D. You can Control G to put that in a group and set the scale X to -1. That will mirror it. Just make sure if you do that, you Shift P to unparent it, you freeze its transforms, and you delete the group it came from. And let's go ahead and name these guys. So this one is going to be my left clavicle. So I'll make this my L clav CTRL. And this one is going to make my R clav. R clav CTRL. Now from here, exact same FK setup system. We'll just go ahead and create our nulls, Control G. We'll select that joint, Shift select the null, do a constrained parent. Once again, remember, we want maintain offset off, so we'll hit apply. And notice this one actually did gain rotations, -90, -90. So we're going to start to see a change here as we move away from the spine. With the orientation that I use, the spine basically had Maya's default orientation. Once we get to the arms, that's going to change. So I'll go ahead and delete that constraint. We'll go ahead and parent our control underneath. We'll freeze its transforms, and then we'll go ahead and take this back into the joint. So we'll select this, do a constrained parent, and that will go ahead and get this up and running to control the clavicle. We can repeat the process over here. Control G, select the joint, Shift select the clavicle, do that parent constraint with maintain offset turned off, delete the constraint, parent the control underneath, freeze its transforms, and then take the control back to the joint and do a constrained parent. Now, once again, this is another area where I showed you guys a broken hierarchy with a follow joint and all sorts of stuff. Do we need that? No, not for a minimum viable product. All we need to do is grab that null, parent it to the chest. Grab that null, parent it to the chest. And what we'll have now is a full working spine. So you can see I can grab the character here. We can bend our spine, we can twist our spine. But we also have the base control here for our clavicles. Now, at this stage, I'm going to save because we finished the MVP of our FK systems. So we're just going to do a save scene as. I have a special folder I've already set up for this rig called MVP. And I'm just going to go ahead and add it to the working folder here. I'll make this my MVP demo 01 and save. So what we can do now is we can go ahead and move over here into the IK systems, which is going to be what we use for the arms and legs. I'll go ahead and start out with the legs. We'll start with the lower torso first. And just a reminder, if you guys didn't already, the props here are kind of separated into a different system. So you can go ahead and hide these if you want to. I'm going to hide them now so we don't see that. So for the IK legs, I like to use a nice boxy control. I'm going to just literally use a box here, Control D, Shift P. And we're going to bring this over, and you want to snap it to the ankle joint, all right? So this here's the ball joint. We want to make sure it's snapped to the ankle joint up here. We then want to scale this and take a little bit of time to make it a little bit boot-like is one of the things I like to do. So I'm going to grab the points here. I'm going to move it down to align with the ankle. And then you'll see I'm switching to isolate select here. That way I can go and grab these. If you guys aren't familiar with that, you'll see me do it in a lot of our other videos, but you can always Google isolate select in Maya to understand it. All right, so something like this is boot enough, and if I want it to be slightly more boot-like, I might just drag this down here, so that way it's a little bit of a wedge, but this is usually how I like to do my leg controls for IK legs. Now, the next step here is to do a modify freeze transform, and just like we did previously, do a Control D, Control G, scale X -1 to mirror, and then unparent this from this area, Shift P, and we can delete these. Now, we can go ahead and modify freeze transforms here. One of the weird things is with IK, we really don't need that null above in terms of the orientation. If you guys would like to add one, you can, but it doesn't really benefit anything. All right. So just kind of be mindful that it's perfectly fine to leave these without an orientation group. It's not really going to make a big difference. And the main reason why is this is going to translate. It's not going to rotate the joint. What is going to rotate the joint is the IK solver. All right. So let's go ahead and name this. I'll name this my LIK leg. We'll go ahead and make this control, CTRL. And we'll do the same for the other one, RIK leg, CTRL. Now, the process of getting this set up is pretty simple. We're just going to come in here to our rigging, our skeleton, create IK handle, and you're going to go from the hip down to the ankle. And as soon as you have that created, it's going to create an IK handle. It will be selected. You're going to go ahead and select the controller and hit P to parent. And what we're doing is we're parenting that IK handle under the controller. The reason we want to do this immediately is our controller is zeroed out, so we can zero these into position. However, if you look at your IK handle, it is not. So you want to do that as soon as possible. So let's go ahead and do that for the other side. We'll go ahead and create IK handle from the hip down to the ankle and just immediately hit P to parent. And there we go. We have working legs. Now, one thing that we want to play around with, though, when we are experimenting with our working legs is the ability for this to actually rotate the foot and the ability for the foot to stay level. You'll notice the foot does not stay level there. So a trick we can do is we can take another IK handle here, and we can go ahead and put it between the ankle and the ball, and we can then parent that to the foot. And what this will do is it will stabilize that so that this stays level, and it will also make it so when we rotate this, it rotates the foot. And then one last thing that can be nice if you do want to set up for a reverse foot setup later is to create another IK handle between the ball and the toe, and we can just parent this back to the foot. So in total, we end up with 3 IK handles. We end up with a main one that's going to be between the hip and the ankle. We end up with another one that is ankle to ball. And then we end up with one last one, which is ball to toe. And once again, these serve as stabilizers so the foot stays level and it can rotate. To show you the difference, we haven't done it on this one yet. When I lift this, notice the foot does not stay level. It sinks down. And notice the rotation sort of works here, but without that level, it doesn't look great. So what we want to do is just continue that by coming in here to skeleton, create IK handle, ankle to ball, P to parent, and then do the exact same thing here from ball to toe, P to parent, and this will have the same stabilization as we saw previously. Now, for whatever reason, I accidentally did not parent that correctly, so hopefully I didn't mess anything up. Looks like we're good to go, and you'll see that functions. Now, the last thing is to get in a pull vector for these, something that allows us to aim this. A very common pull vector I like to use is just something like a little arrow like this guy here, which I'll go ahead and duplicate this out. Now, in the more complex video series, I show you guys a way to make this pull vector follow this and stay in position, all that kind of stuff. Is that needed? No, that is a nice to have. So what I'm going to do this time around is just create a simple pull vector, somewhere in front of the leg. I'll go ahead and Control D, Control G, scale X -1 to mirror this. Make sure you unparent this one. So make sure you Shift P. I actually don't think I unparented this one either. So let's make sure we Shift P both of those. And let's go ahead and give them a name. So this one is just going to be my L leg pull vector. L leg PV. And this one can be my R leg PV. Now, the way we get these up and running is we simply select the pull vector. We go ahead and select the respective IK handle, which will be up here at the ball of the foot, or ankle. And then we do a constrain pull vector. And what that will do now is we'll set up this pull vector here so that this control can aim the knee. Now, like I mentioned, the advantage of the other system is when I move my leg, the pull vector moves with it, but you don't really need that for a minimum viable product. This will be fine. And like I mentioned, for something like a simple game animation, a lot of the times that follow is unnecessary because with game animations, the character doesn't even move through the scene. They just stay put. So let's go ahead and set up that other side. But just to show you, this right now, when I rotate this, is always aiming with the foot. When we introduce the pull vector, what it allows us to do is make the foot aim with the foot, but the pull vector aim with the pull vector. So if you needed your character to have this needs to go to the bathroom look, you can actually achieve that, whereas without the pull vector, you cannot. All right. So what it's going to do is give us independent control over the knee there so that our foot, knee, and hip can be aiming in different spots. Just be mindful to reset it if you do it this way. So let's go ahead and take that back. Let's go ahead and just take the new pull vector here. Let's go ahead and take that handle, go ahead and do a constrain pull vector. And one of the things I want you guys to be aware of is after every control I make, I do a little jiggle here to kind of show you guys it's working. That's not for you guys, that's for me. So just a pro tip, when you are rigging, make sure you jiggle the control so it's doing what you think it will do. And always check the systems together. You'll see this is giving us the correct behavior here, where this is coming down. Now, this is where we're going to diverge a bit, because in the more complex rig, I also went over the process of setting up an FK system. We're not going to bother. I also went over the process of setting up a reverse foot. We're not going to worry about that right now. For now, the feet are good to go. Let's go ahead and save this as a progress point, though. Always save your progress points because it's easier to come back to an earlier revision during rigging than it is to fix something problematic. We can go ahead and set up the system the exact same way on the hands here. So what we can do is we can come in and grab a new handle. I'll grab a box here once again, Shift P. We'll just go ahead and snap it to the hands. Now, there is one adjustment we are going to need to make for the hands, and that's going to be to add a stabilizer. But for the time being, let's just start this out here and create a basic hand control that we can attach our handles to. So you might want to shape this to look more or less like your character, and depending on how you plan to use this control, you also might want to make it encompass more or less of the hand. To keep things real simple, though, let's just make a box. That's the goal of this simple rig, right? Freeze transform, Control D, Control G, scale X -1 to get that mirrored, unparent from the group with Shift P, and freeze transforms. Now from here, what do we need to do to get this up and running? So one of the things we need to do is add a stabilizer joint to our control system. We can do that by simply Control D'ing out the wrist here and deleting away the various finger joints. This is going to be necessary to make it so the hand will be able to rotate. We can then Shift P to unparent this, and we can just go ahead and position it somewhere in the hand and parent it back to the wrist here. If you want to label this, you could just name this RLIK stabilizer. So that way we know what the purpose of this is. Now, this does not need to be symmetrical, but I tend to like to make it symmetrical. So what I'll do is I'll create a locator, snap it to this joint with V to snap to vertex, Control G to place it in the center, and then scale X -1 to bring it across here. What I can then do is duplicate out this control system, or joint system rather, Control D, Shift P, and we can go ahead and make this our RIK stabilizer. Don't mind the spelling, I'm going quick here. Snap this back to here and just P to parent. All right, that's all we need is for it to connect back into the chain and basically be straightforward. So what we can do now is just set this up the same way. We're going to come into skeleton. We're going to create an IK handle. I'm going to go between the shoulder and the wrist, and we're going to select that box and P to parent. And what you'll see is this is going to get this set up, but similar to the foot, notice we can't really aim that hand, right? When I rotate this, it's not aiming the wrist. It's not doing anything. So the purpose of that stabilizer joint was to allow us to come in here and create another IK handle between the hand here and the stabilizer, and then parent that back to the wrist. And when we do that, you're going to notice that the hand now stays level, and the rotations now work on the hand. All right. And that's really all we need to get this up and running. So we can do this exact same thing to the other side. We're just going to go ahead and create two IK handles. We're going to go ahead and do a skeleton, create IK handle from the shoulder to the wrist, parent this to the joint, and then we're going to go ahead and take this from the wrist to the end joint here, and we're going to parent that back in here, to the parent. And what we have now is the ability to control this. So the last thing we need to get this up and running is going to be some pull vectors. So what I'll do is just turn off this so I can find the skeleton. I'll use these diamonds as pull vectors this time. Why not? We'll mix it up. Go ahead and rotate this 90 degrees. We can freeze this transform. Realizing now it's a asymmetrical diamond. We did not need to rotate that, but that's okay. If I am just going straight out too, I can actually duplicate both these at the same time and then snap them to the elbow and just move them out. This bypasses the need to create a locator, so it kind of speeds things up. Just make sure you freeze their transforms before you do anything fancy, and you give them a name so you know who is what. So this is going to be my elbow PV. And you can spell out pull vector if you want. I'm doing an abbreviation. This will be my R elbow PV. And make sure these are unparented from whatever system they came from. I'm noticing they're still in the control group there. And if you unparent, just make sure you freeze transform in case they inherited any world orientations. And from here, just like we did previously, I'm going to turn off my geometry so I can see the IK handle. We'll select the respective pull vector and the respective handle, which will be down here at the wrist. And we'll just do a constrain pull vector. And just remember, you do need to select the control first, the handle selection second, and then press the constraint. But that will now allow these pull vectors to control the elbows. So if we go ahead and take a look at this, you'll see those stay pointing there, and we can move this. Once again, the big difference is in the previous rig, I went ahead and made those actually follow inhabiting. Now, the crazy thing that I want to tell you guys is you're done with a rig. This rig is a rig that can be fully animated with minimal issues. It will work. And this is what I really wanted to get out about the MVP. At this particular stage, we can pose this guy into just about any pose we're looking for, and we can tell a full story with it. What would be nice, though, is some finger controls and maybe a little bit of feet control, but not really a whole lot is needed. So let's take a look at that. In the previous version of this, the more complex version, I show you guys the process of building a reverse foot with several different pivots. But in reality, the only control we really need is probably the ability to lift the ball. If we can do that, we can kind of fudge the position using rotations here and get something that looks good enough in most instances. So what we can do is we can add a singular attribute. Before we do that, let's just clean these up a little bit. With the legs here, the main attributes that we need is translates and rotates. We don't need scale and visibility. So I'll go ahead and highlight these and do a lock and hide to get rid of them. And with both of these selection, we can add a new attribute. In this particular case, I will call this the ball roll attribute. Or I might just call it toe. That's probably good enough. Now with this, we can just set this to float, and we're going to give them a control that allows them to lift the toe. So I'll click add. Now, to do this, we are going to need to come in here to the IK handles we've created, and we're going to have to make a slight change to make these functional. What I essentially want to have happen is I want the ability to basically lift this here. But you'll see that's kind of wonky. I can't tie this to a singular control. So a neat trick we can do is we can take that ball to toe, we can actually control G to put it in a group, and we can take that group's pivot, D, and snap it to this joint back here. So we're going to snap this to the ball, and what this will allow us to do is make this work on rotate X. Now, if I go ahead and turn my skin back on, you can see the effect this is having. So now we have the ability to shape the toe, and that's really all we need for most of these rigs. To get this connected very quickly, we can come in here to Windows, we can come in here to our general editor, connection editor. We can load this as the outputs. And we can go ahead and find that group we created here, and we can load this as the inputs. And the input we're looking for here is going to be rotate X, so I'll go ahead and search for rotate. We'll expand this to rotate X here, and for this one, I'm going to be looking for toe, and we're just going to control toe to rotate X. And now when I go ahead and crank the toe here, you'll see it's going to control that. And really, at the end of the day, that's probably the main control we need, because if you think of this, it's pivoting from the ankle, yes, but we can still make it look like it's bending in, out, we can make it look like it's lifting up. The only issue is we might have to track it on the ground to make it look corrective, but if a reverse foot is too intimidating for you, this works. You know, it just puts a little bit more pressure on the animator, but it's one of those things where unless you're seeing a close-up of the foot, it's probably not going to be noticed. And like I mentioned, this toe control is pretty nifty regardless. So let's set up that guy here again. I'll reload this left, get the toe here. And just like I showed previously, we're going to take the toe. We're going to put that in a group, Control G. We're going to hit D to move its pivot, snap it back here to the ball. That should get this up and working. And then we'll just reload right here. You'll see rotate's already loaded in. Rotate X. And now if we go ahead and take a look at this guy, we can see that this is now going to allow us to control the toe. All right, so that takes care of the foot. So let's go ahead and talk about the hands. In the previous version of this, what I showed you guys is that you could create a locator to track the hand position, and then we could use that locator to basically toggle the joint between the IK and FK systems. In this particular system, we're not using an IK-FK switch. This is a system where we can literally just set up FK controls for the fingers, parent them directly to the IK hand, and have a simple rig that functions. So this will create a separate system from our other IK chain, but it will still function just fine. So let's go ahead and grab some circles. I'll Control D and Shift P, and we'll just go ahead and get this set up here. I'll snap this over here to the fingers. We'll go ahead and rotate these so that we can actually see them. And this will take a moment here, but this is just going to be your standard FK setup. So this is something at this point, I'd hope you guys are all familiar with if you guys have been following along with any of our series. FK is pretty straightforward. We just create a nice system just like we did with the spine. The main thing is making sure you maintain your orientations, and that's pretty much it. Now, with this one here, I'll go ahead and squash it a little bit just to kind of follow that finger shape a little bit better, and I might shape it a little bit better. It's a little bit annoying that they're overlapping, but to keep this demo kind of quick and concise, I'm just going to get these placed quickly here. So you kind of want to match the orientation of the finger, and remember, we're always thinking about the animator first, being able to select these things. So you want to make sure they're clearly on the outside and they give a sense of the directionality of where this thing's going to bend. If you need to, you can turn on the wireframe just to kind of make sure it's kind of aligning a little bit better with those, but something like this should be fine. And what I'll do now is I'll just go ahead and freeze transforms across these. And the next step is to mirror them. So let's go ahead and Control D, Control G, scale X -1. So they're on the other side. And then, just go through the process of setting these up. So this is going to be a little bit boring for you guys, but hey, it's part of the process. Now, you could also name these, which is going to be important. So for example, this would be my L thumb 01. And I'll just Control C that and paste it into this one. This will be my L index 01. And then just copy this and paste these. And the reason I'm using 01 at the end there is you'll see it will propagate the number. This will be my L mit 01. And once again, I can copy this into here. And then we can go ahead and repeat this process for the other side, but swapping L with R. If you didn't want to do that again, you could delete the duplicates we made. You could Control G these, Control D these, and scale -1. The group is necessary to protect the naming convention. You could then highlight these. You could do a modify, search, and replace names and switch L underscore with R underscore and apply. And then you could unparent these. So that way they all have the proper name. That's a quicker way to get that set up. Now with this, the painful part of the FK begins. So let's go ahead and make sure my skin joints are turned off. I don't want to select those on accident. But we can come in here to Windows, General Editors, Hypergraph Hierarchy. This is just my preferred one to work with. Control G to create that null. Select the joint, null, constrain parent. If it's been a minute since you've done this, make sure maintain offset is off, hit apply. And then it's just, once again, that process of deleting the null, selecting the curve, selecting null, parenting, and then freezing transform. So I'm usually going to do this, kind of systematically and somewhat quickly here. I like to do it in sequentials, like what I'm showing you here, because what that allows me to do is use G to just kind of repeat the last command. And yes, this is very hotkey intensive. I'm not going to explain the process of FK at this stage because you guys should be masters of it by now. And it's good to let you guys kind of work independently at these stages. But you can see how quickly I'm kind of plowing through this and we're building this. None of this is sped up. This is literally how fast it goes. Now we're just going to do our null to curve, and bam, we have our FK setup. Now, this is going to be where things kind of diverge a bit from the previous version. Like I mentioned, the previous version, we used a locator to control this. And this version, we'll just take that null, we're going to go to that IK hand and repeat a parent. And what you'll see now is that that controls this. Now, the one cautionary tale is if this comes out too far, that's going to be a problem. And that's where something like that locator could still come in handy. Since we've identified that, let's set up the locator. What I can do is I can go ahead and just set my locator real quick here. We can go ahead and create a locator, snap it here to the wrist. So we track the wrist. We can freeze its transform, and simply take the wrist to the locator and do a constrained parent, but this time make sure you do have maintain offset, which is good practice, hit apply. And then what we could do is we could take a group above this, Control G here, we can go ahead and move that group to here to represent the hand, and we'll just go ahead and name this our hand group. And we can take that locator, we can select that hand group, make sure you're grabbing the locator and not the IK handle, and then you can do a constrained parent with maintain offset to make sure that that group is being controlled by that locator that's being controlled by that joint. And you'll see now we don't run into that issue anymore where overshooting this makes those fingers move, because that locator stays with the joint, not the handle. All right, so good little practice there. Now we're going to repeat this process with the rest of the hand here to get this all up and running. So let me go ahead and just create 3 nulls, and I'll just go to joint to null. Remember, however, I did switch this to maintain offset on. Make sure you turn that off again, and we'll just go through the process here of getting these up and running. We can then sequentially delete those and just parent these guys under. And you can see once you get into a flow state with rigging, it's not that bad. It takes a while to get there. So if you're not there yet, don't worry. But just be aware that at some point this will happen, and you can just have your favorite music, your podcast going in the background instead of me droning on, and just kind of relax and enjoy the process, right? Someday, something to look forward to. Now, this is where things change. I'm going to parent this under the hand group. So we're going to take that null, parent under the hand group. So that hand group is going to act like a master group, and that should allow this to still follow there and fit that in. Nice thing about the thumb is there's only 2 of these bad boys, so we go a little bit faster as we get to the thumb. Sometimes you can do a 3rd one inside for kind of corrective behavior. I'm not doing that here, but it is something you guys can consider. And just be mindful that I do not encourage you guys to work like I'm doing here, working, talking sequentially, all that kind of stuff. It's very easy to make a mistake, and take your time with it, all right? Just be mindful. I've done this a lot, so I have a little bit of confidence here. Cool. So that's going to set up my hand control over here for this side of things. All right, so you can see that full system there. And more importantly, not only do we have the IK hand, but we can come in here and we can see that we also have the FK fingers. You want to double check these work. I just kind of was going off a faith-based system here that what I was doing was correct. Not practicing what I preach. Remember, jiggle these guys, make sure that they're jiggling in the right spots, because if they aren't jiggling in the right spots, you're going to need to go back and set that up correctly. And that's one of the biggest issues I see a lot of students make, is they just try and copy the steps and they don't check their work. Always check your work, professionally or as a student. Now, we learned some stuff over there we can bring into this one. So for example, I already know I need to set up this locator here. We need to snap it into here. I should be naming these. I'm not, because I'm going quickly, but select that joint, select that locator, constrain parent, make sure maintain offset is checked, and hit apply. That'll give us our tracker. And then we can worry about the next step after we get the fingers set up. I'm going to get all the fingers set up real quick here. I'm just going to do one system at a time, though, so that way they're set. And I'll go ahead and speed up the recording at this point so you guys don't have to sit through me doing this. Since you've seen it a few times now, and I'm not explaining the process anymore anyway. All right, so I've gone ahead and built out all of these as the FK system. Just as a heads up, if you built them on first, you can take those top nulls, Control-G to create the group. Then you can take the group and snap it to that locator. You can go ahead and name this. This is the R hand rig, or our finger rig, rather. And we can just go ahead and take that locator. We can select that finger rig. We can do a constrain parent with maintain offset and apply. And what that will do now is it will get this one set up so that all of these fingers move with this guy. So you can see now we have our base control here with those fingers in place. And what we should also be able to see is that I set up these fingers correctly so that they are also bending or able to bend. All right. So at this stage, we have a finished rig. I think we could consider this feature complete. This can be animated any way that we see fit, and it is an excellent basic MVP rig. In terms of MVP, this is probably a more accurate example of what a minimum viable product rig is. Now, what are the final steps? We need to clean this guy up, we need to color code it, and we need to consolidate its hierarchy, and we need to test it. So let's go ahead and do those next. I'm going to save this guy. This is going to be demo 3, and we're going to go ahead and do all those various steps. Now, I'm going to wait on my control rig collection here to get rid of it, but just a secret, you can do an optimize scene size here, hit OK, and that's going to clean out some of the junk groups. We can then create a nice base placement. I'll go ahead and just grab this guy and snap it down here to the center. This will go ahead and be our master control here. I'm going to use X to snap to grid. And we'll just place this underneath it. Now, this is going to be what we consolidate our hierarchy underneath. So let me go ahead and name this. This will just be our, junk buddy master CTRL. You can also name it your global control. That's probably a good example. Global. And we start the consolidation process. So what does this mean? Consolidation means over here in the hierarchy, we just want to see a single little entry, one little line over here, one box. And that is our entire rig. Right now, we have this hot mess of things. So what we're going to do is we're basically going to parent stuff underneath here. That makes sense. And this is going to make it so this rig controls the entire thing, allows us to place it. And then we have our individual controls we can get into. So let's come in here to our general hypergraph hierarchy, because this is a great way to work. And we'll go ahead and start here with kind of our root control. So I can go ahead and hit Control G on this. It's good to kind of create these little safety groups. And I'll just name this trunk underscore rig. And we'll take this group here and we'll parent it underneath this control. So now this control controls that entire chunk. I can then find my various IK controls here. I did not name this, so I should have named this my LIK arm. Thought I named it, didn't. I can go ahead and find its pull vector here, and I can just take these guys and I can Control G, and we could just make this our L arm rig. I can do the same thing over here, find my IK handle, find my control, Control G. This is going to be my R arm rig. While I'm at it, I also did not name this control, so I'm going to name this my RIK arm. And then we can put both of these into a singular control here, or singular group, and I'm just going to name this my arm CTRLs. And then we're going to just take that, parent it underneath here, be the parent. And you'll see now this root control now controls the torso and the arms. It looks like all we have left is the leg. One thing I am noticing is I have whatever these are here. So apparently at some point I duplicated these and didn't notice. And that's a nice thing, is sometimes you find these weird phantom duplicates. Just kidding. Which ones are the fakes? Are these the fakes? Those are the fakes. All right. So make sure you're grabbing the correct ones. And if you ever do that, just make sure your pull vectors work. I must have hit duplicate twice when I did my mirroring. Okay, we can do the exact same thing with the feet now. I'm just going to find the respective foot, the respective pull vector that goes with it. We're going to Control G, and we're going to just name this our L leg CTRL, or rig rather. Rig distinguishes it's a system. Control is the controls itself, so I want to do the rig. Do the same thing here. This will be our R leg rig. And then we can just take these two groups together and name these leg rigs. Now, the reason why these matter is if we had FK systems, we'd want to have more under these, but, master category works out kind of nice. So if we take a look over here, you can see that we are making some good progress. We do have a couple things here. I have this finger rig here and this hand group. So let's take a look at these guys next. I'll just go ahead and take the top group of both those, just Control G, and we'll just name this our finger rigs. We can then take that group and parent it underneath here. We have these locators for the wrist. I'm just going to put these in a master group, Control G, name this locators, and parent that underneath here, be the parent. We have whatever this group 7 is. So this is actually the pull vectors. Apparently they did not get nested into here. So I can find the arm control here, shift select that, and P to parent. So they're underneath there. We then have our control curve collection. We no longer need this. We have all the controls, so I can delete this. And then we end up with these individual chains. So what we're going to do now is consolidate these into groups. I'm going to Control G this one, and I'm going to call this our CTRL underscore rig. I'm going to take the skin here. This is the skin. That's the geometry. So I'm going to hit Control G and name this geo rig. Then here, these are going to be my joints, Control G. We're just going to name this, rig or GNT rig. And we can specify these. So this is going to be my skin joints, skin underscore GNT. And this is going to be my control joints. So this will be my CTRL GNT. And now that we have these master groups, we can create one final group here, which we will call our Junk Buddy rig. And there you go. We have our Simplify rig built. Now, there's some last cleanup that I want to do here, but we're almost done with this process. So the last thing we want to do is just get rid of junk data. On any sort of controls, you're going to end up with junk data. And as a matter of fact, with most of our controls in here, if we really wanted to, we could probably do a select hierarchy and kind of get rid of these. But in the case of this, the main things we want to get rid of is going to be scale and visibility on these. We're going to have translates and rotates on almost all of them. So what you want to do is just come into those attributes you don't want and lock and hide. In the case of the pull vectors, for example, pull vectors only work on translates. So we could literally highlight everything but translates and do a lock and hide on the pull vectors. That goes for both the arms and the legs. So that way the animator knows what they're controlling. When it comes to the root control, we want everything except for scale and visibility. When it comes to the spine controls here, you can kind of leave transform if you wanted to have the ability to be a little bit stretchy. So I usually leave transform because sometimes animators like to use that, even though we're not building a proper stretchy rig here. And what I can do is just highlight all these, get rid of scale and visibility, lock and hide, and then basically repeat that process everywhere else. We just don't want this. Now, why is this important? It lets the animator know what they're doing. But the other factor is every keyframe you set is data. So it makes the file larger if you're keyframing scale and invisibility on everything. Now, is that a big deal? It's not a big deal in most instances, but if you guys are working in video games, it becomes very important because this is all data we don't want to have. On the fingers in particular, I'm also going to get rid of their translates because they really only should be rotating, and that should clean it up. So basically what you should have now is whenever you click on a rig, you see exactly what it can do and what it can't, right? So for example, on the fingers, we know these can rotate. We know they can't translate. On the hands, we know this can translate and it can rotate. On the pull vectors, we know this can just just translate. It can't do anything else, right? And that's just going to make life a little bit easier for the animator. Now, what we can also do is add one last attribute here called a global scale, because it could be nice to make this character bigger and smaller, but the problem is with a rig, you can't just scale a joint, you can't just scale a control, you can't just scale the geometry, you have to scale basically everything. So what I'll do is I'll add an attribute here, and we'll just name this global scale. We'll go ahead and make it a floating with a default value of 1 and no minimum or maximum, and just hit add. And we'll just plug this in to control the things that need to control. So a secret here is, do the joints scale it? Yeah, they scale the geometry, but they don't scale the position. Does the geometry scale it? It scales the geometry, but none of the rig data. Do the controls scale it? It scales the position, but none of the geometry. So what we're going to need to do is basically say, hey, we need to control the control rig scale and the joint scale. And if we do that, we can scale our rig. So let's take a look at that process. We can do so by doing a Windows General Editor Connection Editor. We can go ahead and reload this on the left and grab our global scale. We can take the joint rig, reload right, and we can find scale. And what you're going to want to do is hit the plus icon here and connect it to scale X, Y, and Z on the joint rig. And then we're going to want to do the same for the control rig, reload right, find scale, connect it to scale X, Y, and Z. And what that will do now is it will make it so your global scale can scale your character up and down. That's what we're looking for. All right. The very, very final thing we want to do now is just color code some things. So you can change the color of controls by coming into here, coming into the object display, coming into drawing overrides and enable overrides. And you can pick a color. So in this case, I'll go ahead and pick yellow since it's easy to see, and that will change that base control to yellow. What we can then do is we can do this on our various systems. Now, I mentioned that it can be helpful to put these in groups, and to give you guys an idea, if we come in here to our hypergraph hierarchy and we find the group this is a part of, you can actually change the color of a group itself here. So you can see this left leg rig. If I do a drawing override on this under display and drawing overrides, and we go ahead and set this to a color, I'll use red for the left side on this guy. Or let's use blue. We'll do red for right. You'll see it will recolor everything in that system. So if you've set up these groups nicely, you can actually find these here. You can do an enable override and set it to whatever the color is that you want. And it will actually do everything within that group. Once again, I'm selecting that group. Now, you do need to be a little bit careful here because there's going to be things that are in this group, for example, like the spine here, And let's say I grab this root control and I want to make it yellow. It's also going to make everything else yellow. So do we want that? Do we not want that? It just depends. In this case, I think so. I'll go ahead and just kind of indicate this is different by selecting this one here. And you can see, even though we made those all the same, we can pull that one out. And we can do the same thing here. We're using that blue color here, so I can enable overrides on this and find that nice bright blue, and proceed to do the same thing here. Now, with certain things like this, you can see, I don't know if I put it into the arm rig. Yeah, you'll see the elbow is not part of the same group. So if you didn't get it, no big deal. You can just come through your individual group, individual controls here, regardless of their group, and color them. But with areas like the hand here, you can see there's a lot of these fingers. The nice thing is we set up that hand group, right? So in theory, if I hit the up arrow enough, I'll find this group here, this hand group. And we can go ahead and just make this blue and not have to color all those individually. That can save a lot of time, right? So you can do it individually, or if they're part of a group, you can do everything downwind from that group, which is pretty cool. Or I guess you should say upwind from that group. But that is going to be the final step here of kind of adding in our drawing overrides and making our rig more appealing to animators. And remember, ultimately what we're trying to do is build something for animators. So if we can add a little bit of appeal, a little bit of visual information, it's going to go a long way. All right, so now that we have that set, we can go ahead and just set the visibility to off on our controls, and we should be good to go to test our animation. So I'm going to do a save scene as on this and just make it another iteration here of 05. But I'm also going to save out a master rig. So remember, I like to save my latest iterations here. We can then do a save scene as. I do this in the master file, and right now, if I go to my rigging here, let's see, rigs. There should be one out here. I was saving in Maya binary. I should be saving ASCII. And you can see this is my Junk Buddy rig V01. We're just going to make this our MVP V01 and save. And we're good to go. So the last step we want to do in this process is we want to test our rig. It's very important to do this. So I'm going to create a new scene. And remember, for animation, we always want to reference. Very important as a rigger, we do this test, because if our rig can't be referenced, it can't be animated. So File, Reference Editor, hit the plus icon here, navigate into my character, rig, grab my MVP version 01, reference this guy in, and we should be able to go to town animating this guy. Now, this should be really quick, if I'm going to be honest. This is an MVP rig. It's built for very simple animations. Let's create a walk cycle. First portion of a walk cycle is the contact pose. Can I create that? So I'm going to move these guys out here. I'm going to get these into position, and I'm going to work on what I would consider the contact pose. So in the contact pose, we end up with something a bit like this, where we have this stuff going on here. And you can see how I'm incorporating the foot roll into this. It's a bit of a pain in the butt. However, it is part of a walk cycle. Can the hips swing forward and backwards? Can they lift a little bit? All right. And then the hands. Let's go ahead and just have the hands down to the side. They go opposite each other in a walk, so this one's going to come forward a little bit. We're going to have a chest forward tilt and a chest swing, so it's going to be swinging in the direction of the arm coming forward. I can take a moment here to kind of relax the fingers a little bit. And you can see how quickly I'm working here, right? There's an issue. Ran into my first issue. So my first issue here is I didn't lock and hide my Ike handles. So what I'm going to do is save scene as here. I'm going to put this in test animation, just MVP test. And because we're working with references, what I can do is I can come back into my most recent MVP, either V01 or demo file, and we can disable the visibility on these. So what I'm going to do is I'm just going to come in here to show none. I'm going to switch the show here to show me locators and joints. So Ike handles. And then the other thing I want to show is going to be locators. And I'm just going to highlight all of the stuff here. I'm going to create a layer here called Do Not Touch. And we're going to go ahead and set this to a reference and then hide it. Now, if you didn't get all those, just add them to the layer. And then we can come back here to show all, and that will make it so we're not accidentally grabbing those, because when it comes to selections, it likes to prioritize Ike handles and locators. So if I save, what's really cool here is because I'm using that reference system, I can come in and I can go ahead and come right back to my animation here. Let me go ahead and find the animation file. I called it rest, not test. Now, if I go ahead and highlight this, you'll see I'm not grabbing any of those controls or handles. I'm just grabbing the controls, and I can go ahead and, get my hand to be in a fist or whatever it is I want it to be in. All right, so we'll just make this guy have fists so I don't have to animate him. Makes life simple. A little bit of an angry walk. Why not? All right. But I'll go ahead and get my initial contact kind of going here. And remember, this doesn't need to be pretty per se. We're just doing a test animation for the purpose of testing. Now, if I wanted to save myself some time, I could also maybe just have him have this hand be on his foot. I could also give him a weird dainty walk. So maybe his hand's out to the side here and constantly lifted during this process. But my goal here is not to create a pretty animation. It's just to test what this is capable of, right? So that's really all I care about at the end of the day. So something like this could be, frame 1. Let's come to 0 here and just hit S. And then I'll come out here to something like frame 30 and hit S. So that will give me contact to contact. Let me go ahead and switch this here. And then, in the middle, I could do the second contact, which would be the process of basically pulling this one back, rotating it down, using the toe to bend it in, and a slight rotation here to get it to look like it's kind of pushing off. And then bringing this one forward, zeroing this out, lifting it a little bit, switching the hip swing, so the hip's going this way now, switching this arm to be going back, and making this arm come forward a little bit. And for the most part, that's probably good enough for the second contact. And if I hit play now, we can get a feel for that walk. I can then introduce a couple additional poses just to make this very kind of quick. I'll go ahead and maybe start out with something like a down pose here, in which case the whole body sinks down. So I'd want to go ahead and just sink this down a little bit here. And just to have some fun with it, we'll go ahead and have him rotate down to add in some kind of dramatic squash and stretch type feel. So something like this, just hit S. So he kind of comes down as he's transitioning. And then maybe right around 9 here, we'll go ahead and do kind of a bit of an up pose, a push-off pose, where I grab all these handles. We kind of push up here and have a little bit of fun with it. Maybe I tilt the character back a bit and once again, make it a little bit more dramatic than it needs to be, but it gives us something kind of fun to look at. So now between these areas, we have a down and an up and a down and an up. Also have the playback speed set to infinite, it looks like. Let me make sure it's 24 frames per second times 1. And we can see that in action. So I'm not going to continue this out to a beautiful animation. You guys would want to take more time with it. But at this point, we can confirm this works. This animation is functional. There's nothing wrong with this rig, and it's going to work for our needs. All right, so that is the idea of an MVP system there. Hopefully this gives you guys kind of a look at how a rig can be made substantially more simple than in that first series. And, if you guys got stuck on the first one, give this a try. I think this will be a little bit more bite-sized for you and, get you on that route of rigging, understanding how these systems connect, but without being overwhelmed. So with that, be sure to like and subscribe, and I will see you in the next one.